I'm so excited to join you today for this training. I've done data visualization trainings for hundreds of people, and it's always a very exciting time. And even with being remote, it's really great to have this platform to be able to reach more people. I have a special shirt that I wear for my trainings, and unfortunately, I don't think many people have seen it in person, but it has it talks about how a pizza is a live pie chart. So I hope one day people will be able to see in person, but for now, it's only for my own personal joy. Today's session will be structured based on both group work and some didactic portions. So I'm hoping that you will find it relevant to your work. And of course, if you have any questions, feel free to populate the chat. And we'll be watching, and we can answer them in batches as we go along. So it's really great to see everyone here, and also to see the diverse organizations that you represent. My name is Trisha Ong. I'm a research associate at Johns Hopkins School of Public Health. I support the DataDent project. My focus areas right now are improving large-scale measurement, nutrition measurement, and also on data visualization for policymaking in low-middle income countries. So today's session will focus on data visualization. Data visualization is generally thought to be the graphic process of using data to tell a story. One of the traditional examples that are used as the first instance of data visualization in a public health context is the John Snow Broad Street map, which showed where the cholera outbreak was coming from. It's sort of like the story that always happens on the first day of you learning public health and epi. But ironically, I think in the last 10 years, there was a Lancet article that talked about how they figured out where the cholera was coming from independent of this map. But we'll pretend for the sake of today, and because it's data visualization, that this map helped inform that decision. And then I also included an example of something that you've probably seen, of a lot of busy pie charts that clearly conveys important data. And so one thing that we'll be talking about today is, how do we make this better? I also want to keep in mind that with these exercises, I am going to be sharing with you some data visualization research. So data visualization research is traditionally led by cognitive scientists, from computer scientists. And so there's a lot of interdisciplinary research that goes on to figure out what works better and what aligns with how humans perceive information, which is hopefully what we're all aiming for in terms of trying to develop something that better resonates with our audience and making something that our audience can remember. As I mentioned, we're going to discuss data visualization in the context of key messages. So when you were probably first learning about data visualization in primary school, you probably learned about bar charts and pie charts. And so you learned about them in discrete categories. And so we're going to take a step back and think about what do you first want to communicate, and then decide what's the most appropriate graph or data visualization based on your communication goals. We're going to also discuss what makes a good and bad data visualization. So as I mentioned, we're going to have some group work, and we're going to have some discussion on reactions to certain examples of data visualization. And I'd like to say, in most cases, there aren't right or wrong answers. There are some cases where there are wrong answers and maybe, something that looks a little not great. But for the most case, things can be quite flexible, and it really is dependent on what are your communication needs and who are you trying to communicate to. So I previously volunteered for a group called the Data Visualization Society. It's sort of like it's sort of like a professional society of those who do work in data visualization or data visualization adjacent, like me. And I love discussions on what have people learned from doing data visualization for diverse audiences, or audiences that are in, resource variable settings where maybe internet isn't always reliable, printing quality could be variable. And one memorable quote that came out of that exercise and discussion was, "The graphic is only as useful as the audience finds it." And I find this really helpful because it captures some of my main pet peeves. And I think part of it is because I'm maybe a negative person and I have a negative bent. But sometimes I see data visualizations and they're extremely complicated, or they're really aesthetically beautiful, but I have no idea what it's trying to convey. And even more recently, I saw a lot of this coming out with COVID data. And I think, there's always a balance of trying to come up with something that's, beautiful, that people want to engage with. But at the end of the day, in my opinion, if someone can't understand what or is getting out of that product what you intend, then you sort of failed your mission, because you're not really able to communicate what you want. It could look really great and beautiful on paper, but still, it's really a difficult sell, I think, if if someone can't understand or interpret what you're intending. So the first exercise, and we're going to take 5 minutes for this. It's going to be quite short, and then we'll reconvene as a group to do a poll. So you'll have 5 minutes to convince your team members if you have an opposing view. My work in data visualization started with a National Evaluation Platform project. So it was funded by the Government of Canada to create essentially help desks in 4 sub-Saharan African countries, where the Hopkins team would help technical task teams in each of the countries identify priority policy, maternal, newborn, reproductive health, and nutrition questions, and identify what data and the data analysis steps to answer those policy questions for ultimate dissemination in front of high-level policymakers. When the project had an external review, the external reviewer said, "You all do a really great job. You're clearly investing a lot in capacity building, but there is really difficult evidence of seeing policy translation or policy impact," which I think is professionals, we can all understand is sometimes a struggle. So one of the things that we also noticed anecdotally when doing workshops is even though we were working with career statisticians or career public health officials, there was variable quality in someone's ability to present or be able to summarize information from their data analyses. So we could go in and help with data analyses, but then interpreting that output and getting someone to care was, I think, another jump. So that's sort of what inspired the data visualization work, where we developed data visualization trainings for all of the countries. In Tanzania, in particular, we did a data visualization study, and this was the first data visualization study done in any low middle income country context with any public health related data. And the focus of the study was to test, what is policymakers' interpretation capacity and preferences, with the goal to use that information to inform how we were going to disseminate the results at the end of the cycle. So we're going to do one of these simulations, which is similar to what we did in the Tanzania study, where I'm going to show you two sets of data, I suppose. And each set has one key message and 2 different ways to visualize it. So within your group, you're going to discuss which option you think is better and better represents the key message that's already been identified. So for the first key message, there are these 2 graphs. 1 in 4 countries have data that show that they are on track to reach World Health Assembly targets for child malnutrition. However, we lack the data to assess progress in a quarter of countries. That's the key message for these 2 graphs. So you're choosing which one, A or B, or I think they're numbered 1 or 2, is better. And then the second key message is gender inequalities exist among men and women in ownership or tenure rights for agricultural land. In some countries with data available, there is a reduction in the inequality gap over time. So you're going to be separated through Zoom into Zoom breakout rooms. You'll have 5 minutes, and then you'll be booted back into the main room, and then you will vote. on each of these 2 key messages and what you think makes the most sense.
Great, so I will send everyone into breakout rooms now.
So Hallie's going to post the quiz question, and so this is for this first key message, and I'd like you to vote which one you think is better. If you disagreed with your group, this is your own opportunity to share your own opinion, and then we will come back to these examples at the end of the session, actually, in 2 hours from now. I find this always very exciting because I change the examples almost every single time, but it's always, the shift always changes, and people feel very passionately usually about one or the other option. So it looks like things are settling down. We have 47% who went for option 1. So these are donut graphs, but I'll talk more about that later. And then 53% who chose 100% stacked bar. So pretty much an even split. Can we put the second question up? Okay, it seems like everyone who's voted has voted now. So almost, oh no, that's exactly the same split as the first key message. So 47% went for the first, and then 53% for the second option. So I guess the second option was chosen in both cases, but pretty much an even split. So we're going to revisit this exercise actually at the end, and we'll discuss, what might be the right answer, what might be a better answer, what might be a worse answer. But thank you for participating. So the first thing that we're going to discuss are key messages. What makes a good data visualization? It's a data visualization that has a strong key message. And the key message is something that you want your participants or your target audience, to remember. It's the so what. So when I have done trainings based on key messages, sometimes I'll be really mean and I'll show someone a graph and I'll ask people in the room to write down what they think is a key message. I'll have them stand up and vocally share with everyone in the room what their key message is, and then I'll wait maybe 10 minutes and then pick on someone and ask them to repeat what that person's key message was. But why I do this is because it can be really challenging, I think, for people to remember and choose one item, I think, for someone to remember or select information for people to remember. Part of this is human memory, but also, if you choose too much, if you want to convey too much, you'll end up with it's called information overload, where someone is inundated and has so much information coming at them. So think of this as maybe a key message that's actually a key paragraph, that they don't really know what to retain because there's just too much information that you're bombarding them. So as a start, when we decide what's the most appropriate data visualization, you want to develop first your key message and what you want to convey. When you're trying to tell a story about multiple data sources, or for example, an entire PowerPoint presentation, one step you could do is to first identify all the key messages that you want to convey, and then to arrange them into a story. So when creating, TV shows or movies, it's called storyboarding, where maybe you have all your key messages arranged, and then you can figure out how you can come up with a cohesive story. So as an example, this is something from the annual Joint Malnutrition Estimates that are produced by UNICEF and WHO and World Bank. So just very quickly, I want you to share in the chat screen, if you feel comfortable, what do you think is the key message from this graph? This is based on your own personal opinion on what are you getting out of this graph. It's completely acceptable to write, I'm getting nothing out of this is garbage. But I am interested to hear from you. What do you think they're trying to convey? So I'm gonna stop for maybe a minute or so and see if anyone is brave enough to share in the chat what they think the key message is from this graph. Okay, so there's a mix of answers. Some things that I'm seeing is related to trends and how stunting has changed. Some people have cited number of stunted children changing. Some people have mentioned other things related to region. So I'm going to keep that in mind. So what I want to show you is this is the actual graph from the JME report. The number of children with stunting is declining in all regions except Africa. So that was their key message. And why I wanted to share this with you, so I fooled you and I took away the title, I took away their key message, is based on one specific graph, people can take away many different things. And so that's, if you're trying to think of having someone, if your purpose is to communicate one specific message, it's important to think about how you might make a graph to support that key message. So in general, there's actually not very many categories of different types of key messages. A lot of the times you want to convey comparisons. So how two or more numbers might be the same or different. Or proportion on how one number or certain numbers compare to a total, or trends over time. You may also want to convey specific numbers where you want someone to remember one number and it's very important. So in the black box, I've written how I would categorize this key message. So there is some type of comparison of one number to a total, and also how there is change over time. In this case, there's only two different time periods. But one thing I wanted to note about this graphic, and these observations of this graphic and their choice of key message, it isn't criticism by any means, but one thing I wanted to point out to you is this information is being shown, multiple different ways. So you have a lot sort of going on. If you look at the top bar, those arrows are, I think, intended to convey the change between the two time periods. So the gray circle represents the first time period, and then the yellow orange represents 2020. So that arrow is supposed to show some type of direction. If you look at the bottom, there also is different information because it's a subnational sub-region. So you get additional information from the bottom, but it's interesting because you do have a lot going on. And I think what we see this coming up is, when I asked you in the chat box, what do you think is the key message? There were some similarities of what people got out of this graph, but also, people got out of this graph different things. So the first category, and how this session will be arranged for the rest of the next 2 hours, is we will discuss what are the most appropriate types of data visualization approaches to choose based on your key message. And the first key message group is that we're going to do is how 2 or more numbers are the same or different. So everyone is familiar with a bar chart. You would use a bar chart for displaying categorical data. Sometimes I've seen bar charts not used for categorical data, and there are other stronger approaches for that. And the height of the bars are supposed to be proportional to the number of events or number of items in that category. So in this presentation, when there's a box that has a brain, that means I have picked out something from data visualization research that aligns with this example. So bar charts are very widely used, and nothing is wrong with a good bar chart. Particularly, I think you see a lot of cases where individuals have given up on bar charts because they're not very exciting or they're not as visually appealing. But in fact, they are very appropriate to show categorical data. And studies have shown that bar charts are effective for 2 categories, and at most 2 categories. And I'm sure maybe you've seen some examples where you have a whole chart just full of bars. And then part of it is that there's information overload. Studies show that our brains can only process 3 to 5 groups with 2 columns per group. So that once there's more, our brains have more difficult time processing. So as an alternative of a different type of way to compare categories, another option is a slope graph. Why a slope graph is a good option for 2 separate categories and 1 variable is our brains automatically are attuned to judging the slope of a line. If you show someone a line graph, the first comment they're going to make is, this is increasing, or this is decreasing, or this is staying the same. And that's just because our minds are looked at the angles. So here's an example of how you could use a slope graph to visualize the same sort of information that's represented as a bar graph. So you have the bar graph on the left, just visualizes minimum dietary diversity among children 6 to 23 months. We have 2 different time periods, 2013 and 2018. And you'll notice on the right, 2 different time periods, and they represent both of the sides. And then each line represents one of these categories. And so these are, this is a great way, and it's very easy to do in Excel or another different type of program. Again, this is a slope graph. Another type of graph that I'd want to share with you is called a dot plot. These are also called equiplots. University of Pelotas, part of the Countdown team, calls them equiplots, and they have a whole section on their website of why they're called equiplots. Why they're called equiplots is they are used very commonly to show estimates among different groups. And so they are commonly used to visualize equity. That's equiplots. Dot plots are very great at emphasizing gaps between numbers. So that gap, it represents the gap in coverage estimates between, the 2 dots. So why this is a good technique is our brains really easily interpret space between a line on a common axis. So we look, our brains are trained to look left and right and up and down. So we're looking in 2 different dimensions. And so with a dot plot, we can easily kind of judge on a common axis the space between all of the dots. So if I was looking at this example on the right, I would notice that, hey, all of these dots are kind of grouped together in certain places. In this example, the dark blue represents the percentage of women aged 15 to 49 with anemia in Mali among the poorest. So the dark blue represents the poorest group. The green, which is on the furthest right, represents the highest wealth quintile. So there are a lot of different judgments that are possible from this type of graph. For example, I could notice how in the 2006 DHS, the length of the line between the poorest and the richest dots, so the dark blue and the green, is shorter than the length of the line in 2018. So in terms of interpretation, that kind of suggests that the inequity is getting worse. The gap in coverage estimates between among the poorest and the richest is getting longer. This is an example from the most recent JME report of a dot plot as well. And so each of these dots represent a country. And so again, our brains are looking on the same axis, and we're looking left, right, and all of the dots, all the countries are kind of in one parallel line. One interesting aspect of this graph in their example is they include these black bars, which show regional estimates. So that's a way of integrating two different types of graphs. An alternative approach to doing that is using possibly a different shape, or a line. Lines and X's are commonly used to show targets. So this is just a real example recently of using a dot plot. There are different kinds of dot plots. So a dot plot that only has two dots is called a dumbbell plot. And it's called a dumbbell plot because it's like the weight at the gym, where each dot represents a group. And so you're only comparing two different groups. So this is another example from this year's JME report, which had a lot of dot plots. And again, similar to the equiplot, the plot I just showed you, the focus of these dumbbell plots is on this gap, the gap between two different groups. One thing, just additional note that I'd like to share and point out is within this dumbbell plot, there are arrows that show directionality. And so it's implying, between the 2 years, some type of trend. And you don't really see arrows very often within dumbbell plots. So I think it's a really unique example. Another example of a dot plot is a lollipop plot. It's called a lollipop plot because it's like the candy. It looks like the candy. And so a lollipop plot would be an alternative to a traditional bar chart. You might look at this and be like, oh, this could definitely be a bar chart where each of the different sub-national regions could have been its own bar. Again, in terms of interpretability, the lollipop plots and any dot plots resonate with the fact that our brains are looking on a common axis and judging the length of that line. And so this is an alternative to using just a bar chart. So we're moving on from dot plots, a back-to-back bar chart. You might have seen a back-to-back bar chart in a population pyramid, and the purpose of a back-to-back bar chart is to highlight distribution and also think of symmetry. And so why this is a good strategy is our brains are tuned into symmetry. The traditional metric of finding a fashion model was to judge the symmetry of their face. And part of it is because our brains think about comparing symmetry of items that we visually see. That's why a population pyramid is a good approach, because we can compare two different sides. So this is an example of an application of using a back-to-back bar chart where we have two different groups. We have male children and female children, and we're looking at the minimum meal frequency in Nigeria. In this case, so how our brains first would look at this and how we would interpret is we would judge, does this look symmetrical? It pretty much does. There is some difference in the females in 2013, but for the most part, if our brains are looking at the length of these lines, they're about even. And so we can kind of quickly think that, maybe there isn't a difference between male and female children in this indicator. However, if we specifically wanted to convey in our key message that there are, very distinct differences between male and female children in a different indicator, and we know from, having our data output that the percentages are quite different, we may want to choose a back-to-back bar chart because we may want to emphasize, hey, this one group is really struggling and should be focusing on, and that's the actionable policy based on this data. And finally, maps are traditionally used to show estimates for geographic boundaries. In terms of visualizing data with different geographic boundaries, maps is traditionally the main approach, also bar charts, and it's also a matter of thinking of the key message. In many contexts and situations where I've worked with, where there is sub-national data, one of the intentions is to do, they call it like a shame and blame. Policymakers might want to emphasize how certain regions are doing much better than other regions, in which case, maybe a map could be used to visualize that, and choosing selective colors to show how certain regions are doing better. Another strategy for shame and blame is organizing data based on highest performing to lowest performing. So you might want to strategically, instead of organizing subnational regions based on alphabetical order, you may purposely want to arrange the data so that the highest performers might be at the top and the lowest performers might be at the bottom. So I'm going to pause here, and we're going to proceed with exercise 2. You are going to be put in groups. I believe the same groups as before. And so what you're going to do, and these examples are in the exercise PDF, so make sure that you drop that before you are put in your rooms. There are 2 case studies. And the case studies are based on the NSO and World Bank current phone surveys. They call them HFPS, COVID-19 data that they collect monthly. So within the 2 case studies, I've specified a key message, and you'll find that in yellow. I've included the data for you, a selection of the data. And the question that I'd like you to discuss in your group is what would be your approach to visualizing that data if you wanted to convey that key message? You do not need to actually make this graph. Feel free to sketch it if it helps. But really what our focus on in this group work is discussing with your teammates what you think is the better option and why. And then we'll reconvene in as a group and then discuss what you chose.
Waiting mid-80s.
Oh, okay. I'll wait for a little bit then.
There we go.
Welcome back, everyone. As you're trickling in, I'm going to take this time before we move on and discuss the exercise and group work just to address some of the questions that have come in so far. So thank you so much for sharing such thoughtful questions. One question is, what can be used to create dot graphs? So dot plots can be created using Excel, using Tableau, using R. That's what I have primarily used. In terms of Tableau, so when I do data visualization trainings, I generally do not teach, the focus originally when I was doing trainings was not on Tableau because Tableau is quite expensive, but there is a free version of Tableau called Tableau Public. And so on the DataDent website, and I will share a link later, there is a tutorial on how to make dot plots using Tableau. So we'll make sure that to cover that later. Another question is on how easy is it to pick countries where trends are getting worse in dot plots? So that's a really interesting question, and what I've pulled up for you is the example that I showed from the JME where they use dot plots, and the key message is about how the regional estimates can mask country variations in country prevalence. So in this case, I think with the graph that they chose, they wanted to show how there is a wide distribution. So the key message focus is on this distribution of how, yes, we have this regional estimate, but what goes into that regional estimate is a lot of variation. In this case, I don't think that their intention is to really create a graph where one can pick out the specific estimates within a country. It's really to show the distribution. So I think that's a really good question on how this dot plot actually sort of masks the individual country performance, and it's not really clear. Another thing to keep in mind is this is a static graph. So it's not like I can take my mouse cursor and hover over a circle and find out what the actual estimate is. So in this case, I would say that, yeah, I think it does mask some of the individual country estimates that come up, that make up these regional estimates. Another question was on using arrows to show dumbbell directionality. I think it is very helpful if you are using time periods. But again, a dumbbell plot could be used to show two different groups that might not be temporal. So that's why I didn't emphasize the arrowheads before. And then a really great comment was how using maps can mask individual country performance just based on space on the screen or space on the graphic. And I agree, and I think that's really true. And I think one thing that I feel is true is once someone has a data set, it's not unfortunately as objective as you think. People can distort data for their own purposes all the time, and we'll briefly touch visualizing in an equitable way a little bit later in terms of today. But I'm going to jump back into the exercise. So does anyone want to volunteer and share what their group discussed in terms of this first case study?
I can volunteer. Can you hear me? So we had, I don't think we agreed on anything, but we talked about maybe doing a stacked bar graph or combining the very bad and not good together, and then the good to exceptionally good together, and maybe doing a pie chart, or so stacking them together just to show that highlight that it's more than 50% that had a not good, a drop in the crop sales. So we talked about maybe stacked graph or a stacked bar graph, or maybe a pie chart, or maybe a bar graph. So we didn't come to a conclusion, but that was kind of the discussion we were going on.
Great, thanks so much for sharing. Does anyone else have anything to add to that, or want to contradict what was shared?
I don't mind saying something. Yeah, so in our group, we thought of using a pie chart, but because the message was to highlight that more than half of the responders had drop sales, so we thought we would use two different colors, but with different shades. But still on the pie chart.
Great. It's also great that you are flagging types of graphs that haven't come up yet in terms of this category and within the lecture. But just as background, in terms of how this data was visualized in their report, it was a bar graph where each bar, each different category represented a bar. But a very interesting suggestion that came up was, what if we collated the bottom two? And so we didn't show all of the individual categories. And so I do want to highlight this as something to think about is you don't necessarily need to show all data. I think that can be, I guess it goes to the mantra of less can be more. One common mistake I see is that individuals kind of visualize too much data because they just want to show it all. And again, that can be sort of an issue sometimes with information overload. And there is a whole report that I think I shared as the background information on information overload and how the DHIS2 folks wanted to optimize using DHIS2 dashboards, because one thing that they were struggling with is people were inundated with too much information and didn't know what to get out of it. In terms of the second case study, does anyone want to share any of the group discussion that came out of it?
Hello.
Like there's a yes.
Okay. In our group, I think we suggested that it might be simple enough to use a bar chart for this particular data that is being displayed, but it's not exhaustive. Maybe some other display could be used. Also, we said it could depend on the kind of visualizing software that you have. And maybe for some that are just limited to Excel, the type of a bar chart might just be used. Otherwise, when you have some other sophisticated equipment, then you can now go on to use maybe any of the plots as has been mentioned in the lecture. Thank you.
Thanks. Does anyone else have anything to add to that?
Yes, Trisha, if I can. The two things I wanted to flag is that I think in our group, strictly speaking, we didn't complete the assignment, but we didn't do so for reasons that were quite interesting. The first of which was that we drew attention or queried this category of moderate/severe in the sense that we noticed that the totals for the overall actually come to 103%. And it wasn't clear to us, therefore, if the severe row was in fact included in the moderate row as well. In other words, was moderate/severe, was that 31% contained within the 72%? The text above was not helpful, didn't clarify that issue. So therefore, we felt we couldn't meaningfully graph the rest of it without clarifying the disposition of the data. We also took issue with the key message. We thought the key message was wrong. The data that struck us was that the distribution of moderate to severe and severe food insecurity was distributed across Q1 through Q3. So therefore, it seemed to us that the key message was that food insecurity was widely distributed across wealth quintiles. So we wanted to reformulate the key message, and once we did that and we clarified the data, then we'd be able to graph. But based on what we had here, we felt it was incomplete. And therefore we couldn't meaningfully then visually represent it. Over.
Thanks. I really appreciate that feedback. And I think one issue is my attention to detail and listing and just pulling this table directly out of their report. So I should have done the math to confirm. In terms of the key message, I think the focus, so in terms of moderate to severe, that is specifically how they had represented the data within the table of the report. And so disaggregating the severe, I have to go back to the report and confirm that.
Okay, thank you.
I think in terms of the key message that, our team had identified with rural and urban households, high levels of food insecurity, I think we had conveyed that as, over 50% is quite high. And so, I don't necessarily, I think having over 50% of moderate severe food insecurity, is high levels of food insecurity. So, that's, I would agree with that key message.
Okay, thank you.
Does anyone else have anything to add in terms of the type of way you would visualize this data based on the key message that's specified?
Hello. We in our group we thought that echo plots should be used since these are quintiles, different quintiles, and we can show the echo dot plots as one of the choice of graphs for this case study.
Great. Thanks so much for sharing. So in terms of how we would like to see equity visualized we would normally want to see it visualized as a dot plot just because of the space between dots in a common plane. I think one consideration that has been brought up is, what is within your capacity in terms of what software you have access to and the approach. And so there's two different dimensions of this. What type of software do you have access to make the type of graph? And also in terms of your audience interpretability. In terms of the NEP Tanzania study that we did, we included equiplots as part of the examples we wanted to test because we had noticed in global health in general, equiplots have been used increasingly more in terms of deliverable products. And so one thing that we wanted to test is, can people actually interpret them? And one thing that came up is, before we started the study, the National Bureau of Statistics in Tanzania that we collaborated with said, there's no point of doing this study because everyone's always going to choose a bar graph or a pie chart, regardless of the key message, regardless of what you wanted to communicate. And in most cases, that's what people chose in terms of preferences. They always wanted to see a bar chart or a pie chart. And part of it is familiarity, but then also in terms of interpretability, helping guide people through the interpretation, particularly with dot plots, is something that, that came out of this study, because just because individuals might have had a more difficult time with certain types of graphs, I think it pointed out to the team, I think this is an opportunity to ensure that when we are disseminating the information, we can convey how to interpret the graph. And so we'll go through today a little bit on how you can help with interpretation. But in terms of how you could visualize this data, you could use just a bar chart. But as part of alternative strategies, using a dot plot or some type of equiplot is also, a viable option. So I'm going to move on with the second category in terms of how you would choose a type of graph based on a key message of proportion, or how you would compare one number to a total. And so, as I mentioned, with pie charts, everyone is familiar that the size of a slice is proportional to the amount of data. And you would use different colors of a slice to represent different types of categories. However, I'm sure all of you, and I include this example at the beginning, of what happens when you have pie charts that have numerous different slices. It becomes very difficult to interpret because the size of the slice is so small, or there's not much variability, where it's very difficult to be able to interpret the actual proportion. In terms of data visualization research, it suggested that our brains have a more difficult time comparing pie charts, interpreting pie charts compared to bar charts or line graphs. And again, this goes to the point of our brains being attuned to straight lines, things on a similar plane in 90-degree angles. Another thing in terms of how our brains interpret pie charts, we rely on a central axis to figure out the actual proportion of that wedge. So an alternative option to a pie chart that you sometimes see is a donut chart, which I included as part of the first exercise. A donut chart can be even more challenging to interpret than a pie chart because that central axis is missing. And so it takes our brain an extra leap to be able to understand what proportion of that wedge is actually represented. So in terms of other examples that you could use that are not pie charts, a stacked bar chart is a good option if you have, these categories. We are trying to compare different regions, and you would never want to use a pie chart versus a pie chart. And why you would not use a pie chart versus a pie chart is because, again, our brains are looking up and down and left and right. And so in this stacked bar chart example, it's easier to see all of these bars in a vertical arrangement compared to having many different pie charts represented in each of these regional categories. A variation of a stacked bar chart is a 100% stacked bar chart. And so this, again, an alternative would be creating a pie chart for each of these different groups. But alternatively, there is one line that represents 100%, and then two different colors that show two different groups. So we're looking up and down and left and right, and we can see how the blue gets more narrow looking down, and the red gets has an increasing proportion towards the bottom. And then finally, a new type of option that has come up in terms of comparing two different categories of data is this proportion plot. And the proportion plot is very similar to the slope graph that I mentioned earlier in the lecture. And so on the two different sides of the graph, you have share of deaths by police and share of population. And so we're comparing two different types of proportions. And these proportion plots can be done in Excel. And I think there's a link to a tutorial on how to do that. So here's an example of the Jhukovic Dashboard. And so this is something that I helped volunteer to advise on what were some quick changes that they could consider to have more interpretable data based on their needs. So on the left side is where they started, and on the right side were the changes. In terms of the Jhukovic Dashboard, it was quite a political process where the dashboard sat, in the president's office, and there were a lot of stakeholders that were part of this decision on how everything had to look. There were some aesthetic branding type parameters where they had to stay in the color palette of Hopkins, but then also these indicators that they chose were very specific and had to be decided, at the president's level. So one thing that I worked with the team is, how could you quickly incorporate new changes that could at least improve some of the interpretability? So you'll notice like the most distinct changes is, well, if you change the pie chart in the middle, you could fit a lot more different types of data because right now it's taking up much of the real estate within your one graph. We also talked about how to convert these bar charts that they had included as stacked bar charts. So again, in terms of trying to think of what might be quick wins, this is something that you can consider in terms of what indicators are priority to communicate, and then also what type of space requirements and aesthetic formatting that you're working within the parameters of. So we're going to break out again into groups. And if you look at the PDF, there is a new example and a new key message. And so I'd like you to discuss in your group how you would visualize this data. And I think this breakout is shorter of only 10 minutes. And then we'll come back as a group and discuss.
Great, I will send everyone into rooms now, 10 minutes.
Up since the last section as someone asked about a cheat sheet. And so I think maybe post it as a resource. There are 3 cheat sheets I've prepared, and they're actually data visualization decision trees, where it guides you on what type of graph to choose based on the key message. And we have that in 3 different languages. So feel free to reach out if you need help with finding that. But in terms of this exercise, does anyone want to volunteer and share what their group discussed or any challenges that they had? Thalia?
Yeah, just very briefly, we thought that the temporal aspect of this information was very interesting to communicate, so you can kind of show evolution over time. And then we also discussed, how best to do that when it's, it's always sort of 100% of the sample, or whether so it's sort of percentage, whether it's going to be an area chart or a percentage stacked bar chart where it takes up 100% of the axis, or whether it's like a stream graph where it can kind of show where it doesn't really add up to 100% of the total, but the main takeaway would be to show kind of the fluctuations and evolution in time in this.
Great, thanks. Does anyone else have anything to add to that?
Another thing we talked about is that we would maybe just show all of the time and none of the time, because the key messages is just trying to highlight those two categories. And then we would do a trend line to show like the fluctuation as well.
Great. So I would say, because the key message identified is related to proportion, I wouldn't necessarily choose a line graph, and we'll discuss, line graphs do emphasize change over time, and I think time is an important aspect. But in terms of this particular example, because the key message is really on the proportion of the population, that's why I wouldn't necessarily use a line graph. An alternative option, actually, if you wanted to use a line graph and to show proportion, is to use something called an area chart. And so that would be another option. So I think all the suggestions that have come have been really great. I think one thing to keep in mind with this data and the key message is you wouldn't want to create 6 different pie charts to visualize this data, because it, as I mentioned, in terms of the way that our brains would look at and interpret this data, comparing 6 different pie charts would be the most challenging approach. Again, the key message does emphasize 2 different aspects of this data, the all and never. So that is one thing to keep in mind. And Thalia mentioned, what do? You have all of this data, and it does show different types of proportions. So you do have to make sure you choose an approach that emphasizes that, if that's what you want to convey. The table does include additional information in their reporting, such as most of the time, about half of the time. And if that intention is not to, highlight that, it's okay to omit that, as long as you accurately include the rest of the proportions. I'm looking at the chat right now, and so there is a suggestion of using a radar chart, a spider web. So I actually did not include radar charts as part of this presentation, and I generally don't teach them, because radar charts are extremely difficult for people to interpret, particularly with variable data literacy. So I didn't include them in this presentation. However, it is a potential, it is an approach you could use based on this type of data. Another question that's come in related to this is how to represent graphs on sensitive issues, like wearing a mask. So for the purposes of this exercise, we had specified, wanting to emphasize wearing a mask versus not wearing a mask, because that is, what we had decided, we wanted you to convey. But there are some, topics that might be more sensitive than others. And also in certain areas, there are restrictions on what type of data can be conveyed and the data source. So there are 2 different aspects of that. In some areas and contexts, all data that's publicly visualized has to be government data. So that's one aspect to keep in mind in data source. In terms of that, it's always necessary to be transparent about where the data is coming from, because that also is one frequent question that comes up in dissemination meetings. In my experience, is the first thing people will ask, particularly if data doesn't look too favorable, is someone will question the quality of the data. So I think it's very important in terms of when you come up with your data visualization to be very transparent on the data source and to convey, where it's coming from. In terms of topics, I think that is dependent, also context dependent on, what's socially or culturally appropriate, but then also, what is your intended communication goal? I think there are some topics that end up being very sensitive, particularly when it's disaggregated. And also with dissemination meetings, it's very sensitive when a sub-national regional leader might be present at a dissemination and they're noticing that their region is not doing great. And so it's all things that you have to keep in mind, and how do you weigh that? And again, as I mentioned, some stakeholders that I've worked with, their strategy very much is shame and blame. So they want to emphasize certain subnational regions that aren't doing well because they think that's motivating. But, you know, I think it's important to have stakeholder conversations on what's most appropriate before disseminating. So I'm going to move on to the final category in terms of key messages, and it's change over time. So a line graph is traditionally what you want to use, but I mentioned a slope graph before earlier in this presentation, and the slope graph would only be used for 2 different years in this case because the slope is based on two points. And as I mentioned, an area graph. So an area graph integrates this idea of proportion and also change over time. So on the left is an example of a regular area chart. And then the right side is what would be equivalent to like 100%. It shows proportion within 100%. Finally, when one number is really important. This might seem very silly to you, but humans have very short-term memory. And so sometimes you might want to convey one number that you specifically want someone to take away from that. And so here's an example of this year's JME report where there are certain numbers that are in a bigger font because that is what they want to emphasize in terms of proportion. And they're using the font size to emphasize that type of key message. In terms of other strategies to emphasize specific numbers, using icons also is commonly used. With the DHS, with every single report now, they release a key indicators report. And so the key indicators report and the briefs that they produce have a lot of infographic type visuals like this, where it might be certain single icons that are used for a certain impact to show things that could otherwise be visualized in a more traditional graph format. So I'm going to ask Hallie to send you to your breakout rooms. There is one final case study, and then we will come back and discuss like before. Does anyone want to volunteer and share what their groups discussed?
Okay, I can try.
Great.
Okay, so our group thought of a line graph first, but then we decided to go for a bar graph, the side-by-side bar graph. And we decided for a side-by-side bar graph because we saw the differences were quite minimal. And since we have to highlight that there was a change, we thought the bar graph would show that better than a line graph.
All right, so our group did a slope graph because it was important to show the change. But we have 3 different slopes in the same graph and probably 3 different colors for the overall, urban, and rural. And then the time remains at the X at the bottom.
Great, thanks. Jason, do you want to share?
Yeah, I don't know if you can see. Yeah, here we go. So we do the slopes as well, but then the actual key message is more about the change, which is this thing here. So urban has changed by 3 times as much as rural. So we kind of figured that if that's your key message, a graph of the message itself might be useful, but then also the kind of data themselves show something more really, which is that all these numbers are quite high and that urban has overtaken rural in absolute terms.
Thanks for sharing, and I appreciate the sketch, and I recommend, when you personally are trying to plot out your approach, sketching can be really helpful. So there are a few ideas that came out, I believe, and I'm going to add another difficult thing to consider as an option. It might not even be appropriate to create a graph. So it was a little, another consideration. As I mentioned, one reason you would do data visualization is our brains interpret graphics quicker than tables. But one thing to keep in mind with this data that I pulled from the report is the data, the differences among these estimates isn't very large, which Jason had mentioned and someone else had brought up. And so that's something to keep in mind, because even if you did do a slope graph, which is a viable option and probably something I would have chosen, if you think about what the slope graph would look like, and I think Jason's illustration was really nice, but if you consider doing it in Excel, because the estimates are so small, the differences, actually, visualizing these estimates would be pretty difficult, because you wouldn't really see that much change. I mean, you could do the graphs that you want, add the estimates, the actual values. But again, another option could be just showing a table. A back-to-back bar chart. So thinking about that option, as I mentioned, the back-to-back bar chart emphasizes symmetry. So if you showed urban and rural on two different sides of this back-to-back bar chart, one thing that it would show is, yeah, it is pretty symmetrical. So the differences between urban and rural might not show up as much if the key message is really these larger gains. But again, larger gains in this case in the data, I mean, the estimate difference is quite small. So in terms of the final bits of the session, I have a whole catch-all of different tips to consider when you are creating your graphs. And the first thing I want to address is confidence intervals. I think coming from an academic environment, it's quite natural to think about wanting to convey confidence intervals. But one thing to consider is your audience might not understand confidence intervals or statistical significance. So it's something to consider during the actual dissemination, and also how do you visualize it? So on the right, I have 4 different options, and there is a study done testing different ways to visualize uncertainty. And respondents in the study had the easiest time with the circled version. So that's the bottom left, and it's a gradient. And so I've seen this approach used particularly by UNICEF in showing confidence intervals. But again, sometimes it might not be necessary or important to show confidence intervals. In terms of this Tanzania data visualization study that we did test on confidence intervals because it was part of one of our main messages in terms of our evaluation findings, where I believe it was maternal mortality, where the estimates did not seem to change. It was something about how, statistically speaking, it didn't change. If you're a policymaker, it's very difficult to think about hearing something like, well, maternal mortality didn't change after investing so much money into, different types of programs and policies. So again, it's something to keep in mind is it necessary to convey a confidence interval based on your key message or to understand the data? And if you are, think about how you present it. So here are some examples on how you might be able to vocalize statistical significance. There is a statistically high chance that the actual number falls within this range. So think about, when you are conveying confidence intervals or in a presentation, how might you present it so someone actually understands? In this Tanzania data visualization study, when we asked about confidence intervals and probed, one respondent said, I feel like I'm in school. There is no reason to discuss confidence intervals. It's like pouring water in a sack. So it's something to keep in mind. Is your audience going to understand confidence intervals? Is it necessary for the key message that you're trying to convey? Here's an example of visualizing confidence intervals from different COVID models that were in play in April 2020. And this is from the New York Times. They use a shading approach. And I thought that this was interesting because what they're trying to convey within this particular graphic is for certain models, the uncertainty was quite high. So if you think of this green shaded region for the IHME estimates, or the blue is the IHME estimates, I believe the green is Los Alamos maybe. But what they're trying to show with these overlapping areas of color is how much uncertainty there is in these estimates. And I think in particular with these COVID models, it was really important to relay, particularly for an audience that maybe less familiarity with modeling, in that models are not, the truth. And so to show this type of overlap, and also there's I think some humor in the fact that this blue shaded region overlaps within even the text of the article. Another thing to keep in mind is color. So something that came up in our Tanzania data visualization study and comes up when I'm working with stakeholders is how do we choose colors that are colorblind friendly? We don't really have good estimates on the prevalence of color blindness globally. And particularly, it's something to keep in mind because in a dissemination meeting, someone's not going to vocalize that they do not understand or they cannot see, a graph because they are colorblind. I think it rarely happens. You can integrate different strategies to make your graphics more colorblind friendly. So one example is integrating patterns. And also it's important to keep in mind that there are certain color palettes that are more colorblind friendly than others. And so you can look this up on Google and there are suggestions that can come up. But in terms of some contexts, have specific color palettes because those are the country national colors and whatnot. And so in those cases, you really want to integrate different techniques like patterns if you are working in the confines of a specific color palette. Here are additional errors that I see that come up. Having accurate axes, particularly for continuous variables. So if you look at the bottom on the left, they're evenly spaced, which is inaccurate. Retaining formatting. So it's important to make sure that you retain the dimensions of your graphs because if you do not, sometimes they end up looking squished and then that can impede in your interpretability. And then also, don't assume that your audience can interpret things on their own. Edward Tufte, who is one of the most famous people who work in data visualization, he is famous for saying, don't underestimate your audience. On the flip side, don't overestimate your audience. It's always very helpful to have annotations to help individuals understand how to interpret different graphs, particularly because data literacy and visualization capacity can be quite variable. And so please consider adding annotations to help with interpretation. And so these are additional examples. This is from the New York Times where when you scroll in terms of these different graphics, these pop-ups show up and then they help with interpretation. And this is a dumbbell plot. Finally, and this comes up, I think someone had commented this in terms of ethic responsibility. And if you have unfavorable data, should it be shown? And so one thing to keep in mind is as a data visualization expert now, you have an ethical obligation to visualize data accurately. As I mentioned, even though you would think data is something objective, unfortunately, people can always manipulate their data to convey a key message that might not be quite accurate. So in this example, in the US, it's called Sharpiegate, where it was about a hurricane. And obviously, this is an example of information that is not really favorable. You don't want to know that a hurricane is coming for you. And then, what Donald Trump did is he took a Sharpie and he kind of moved it. So again, there is an ethical obligation to convey data, even if it may not be favorable. Finally, and this has come up in how do you actually make these types of graphs? And we don't have time today to go through the actual steps, but if you go on the DataDent website, there are tutorials on how to get started with Tableau Public. As I mentioned, Tableau Public is free. And so there are tutorials, there are GIF tutorials that show you where to click and what, and there are example files that you can use to help get you started on how to use Tableau. So we're going to revisit these key messages in this first exercise that we started a session. So Hallie, could you put up the polls again? And we could start with the first poll. Great. It looks like things are tapering off, and then in the interest of time, I'm just going to cut it short. But it looks like more people ended up choosing option 2 after today's session. So again, I think there are trade-offs between 2 different versions. I think with the donut charts, there is some more visual interest. It is a little more exciting than a stacked bar chart, this 100% stacked bar chart. And also the annotated numbers help with interpretation. But if we wanted to easily compare these different categories of color, the 100% stacked bar chart is an easier option to do that since our brains are looking up and down and left and right. Hallie, can we move on to the next poll? Looks like it might be snagged.
Let's see here. Folks should now be able to see it, I think. Sorry about that. I'm not sure what's snagging. Oh.
So it looks like it's
Here.
It says polling is closed.
Okay. I think it should be working now. Sorry about that.
Oh, it's fine. Yeah, it looks like the numbers are populating. Since we're running out of time, I'm just going to discuss this while numbers are coming in. So it looks like more people are choosing the dumbbell plot option now. One issue with the bar chart, and I would say that both options aren't perfect, but with the bar chart in particular, one thing that's really hard to get out of this bar chart, particularly because the key message mentions how some countries that have multiple data points, there's a reduction in the inequality gap. So with the bar chart, based on the way this is formatted and how I shared it with you, it's a little hard to pick out quickly which countries we have multiple data points for. So there is sort of a pause in that as well. But again, with the dumbbell plot, I think one advantage over this bar chart is it's emphasizing this gap. So we notice these long lines, particularly, in Burkina Faso and Nigeria in 2014 and 26 respectively. And so seeing that length of line and emphasizing that gap is something that we want to convey, particularly with this key message. So thank you so much to everyone who's joined today. There's a really good, helpful link in Color Brewer. I highly recommend Color Brewer in terms of trying to find color palettes that are colorblind friendly or for some other creative inspiration. And if you have any other questions, feel free to let me know or reach out to ANH. Oh, Hallie, you're on mute.
Thank you. Thanks everyone for joining. You should see a quick feedback poll on your screen now. We would greatly appreciate if you wouldn't mind filling that out for us. And thanks so much for joining. Thank you, Trisha, for a wonderful session. And we look forward to hopefully seeing everyone on additional learning labs this week and at our research conference next week. Thank you.